Number 20, we're just graphing these points and deciding whether it's linear, quadratic, or exponential. So -3, -1 is right here. -2, 0 is right here. -1, 1 is right here. 0, 2, and then 1, 3. And we can see very clearly what the pattern here is, that is a line, which means this is a linear equation. And that's it. For the next one, again, we plot the points. 0, 3 is up here. 1, 1 is here. 2, 0 is here. 3, 1 is right here. And by looking at these points, we can see that it goes down and then back up. This is clearly going to be a parabola, which means this is a quadratic function. And then the last one is we plot these points. -2, -0.25 is right about here. -1, -0.5 is here. 0, -1. 1, -2 is right here. And we can kind of see this curve starting to form. It looks like it hugs this line and then curves in just this direction. And that would be an exponential function. Okay? And just a reminder before we move on to the next section, because we'll need this, remember linear functions are y equals mx plus b. Your quadratic functions are y equals ax squared plus bx plus c, but we're only dealing with ones that don't have a b value, have a b value of 0. So we'll just do ax squared plus c. And then exponential equations are y equals a times b to the x. All right, and we're going to use that in these next 3 examples. For this, we're looking at what kind of model this is. So I always start off by looking at the differences. Like here, I subtract 2, and then I subtract 6, and then I subtract 8, and then I subtract 16. And there's no common difference here. So then I look at the second difference and say, okay, I go down 4, and then I subtract a 2, and then I subtract an 8, and that really doesn't do anything. So the second difference doesn't give me anything. So then I go back to the drawing board and say, okay, am I multiplying? Well, yeah, I'm multiplying by 2, and then times 2, and then times 2. I'm looking for the pattern here. So since I'm multiplying by the same thing each time, it means that I'm dealing with an exponential function. So this is going to be exponential. And then it asks me to write the equation of the exponential function. Well, coming back up here, remember exponential functions are y equals a times b to the x. So this is going to be y equals, a is my initial amount, which is my y-intercept, which is this guy right here, the -2. The b value is the thing I'm multiplying by each time, which is right here. It's the +2 raised to the x. So my equation is y equals a -2, 2 to the x, and that's it. If I look at the next one, again, I start with the first difference. So here I subtract 3, and I subtract 3, and then subtract 3, subtract 3. So since I have a common first difference, it means that this thing is linear. Remember, linear functions are of the form y equals mx plus b, as I stated in the previous examples. And for that, the slope is the thing we're adding each time. That's the -3. The y-intercept is right here. It's a -2. So it's -3x minus 2, and that's it. And then the last one, when we're looking at something like this, again, we start with the first difference. I'm going up by 0.5, and then I'm going up by 1.5. I add 1.5, and then I add 2.5, and then I add 3.5. And so now there's no first common difference, so I look at the second common difference. Here I add 1. Here I add 1, and here I add 1. Since I have a common second difference, it means that this thing is quadratic, which means I'm going to be of the form y equals ax squared plus c, and c is the y-intercept, which is right here. It's the 1. I'll plug that in a while. And now to find my a value, which is what I need for the equation, I just need to plug an x value, an x and a y value, and I'm going to choose 2, 3. So I'm going to plug the 3 in for y. I'm going to plug the 2 in for x. And I'm just going to solve for a. I've got to subtract the 1 from each side. So that gives me a 2 equals a times 2 squared, which is 4. And now I just divide each side by the 4. So I find out that a equals 2 over 4, which is 1/2. Which means my quadratic equation is y equals, let me go back up and change it right here, is y equals 1/2 x squared plus 1. And that's it, okay? If I take a look at the next one, it asks me to solve this system. And really, since I'm going to solve this system, the best way to do it is by substitution. I've got my y values. It's telling me that y equals this, and I can plug that in for y right here. So I'm going to end up with x squared minus 2x minus 4 equals the 2x minus 1. So these two things are equal to one another. I'm going to solve this for x. I'm going to subtract the 2x from each side. So that gives me x squared minus 4x minus 4 equals a negative 1. Now I'm going to add the 1 to each side. So I've got x squared minus 4x minus 3 equals 0. Now that it's set equal to 0, I'm going to solve. Always check factoring first. I build a bridge. That's a negative 3. Two numbers that multiply to negative 3 but add to a negative 4. I'm not going to be able to come up with those. Okay? Which means I either have to do the quadratic formula or completing the square. Most of you probably did quadratic formula, so that's what I'm going to do. Opposite of b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is a negative 3, all over 2 times a, which is a 1. And I would just plug this in. That's 4 plus or minus the square root of 16 plus 12, all over 2. So that's 4 plus or minus the square root of 28 over 2. Again, the square root of 28, I'm going to round this to 2 decimal places. Just plug it into my calculator. I end up with a 5.29. So I have 4 plus or minus the 5.29 all over 2. And now I have two things to do. Let me, that's for my previous example. Let me section that off. So I have two things to do. I have to do the 4 plus the 5.29 and divide it by 2. And that gives me a 4.645. To 2 decimal places, that would be 4.65. And then I have to do the 4 minus the 5.29 and divide that by 2. And that gives me a negative 0.645, or just a negative 0.65. And so those are my two answers, but I'm not quite done yet. These are just the two x values I get. Remember, for this, I have to have y values that go with them. So I have to plug each of these back in, okay? And I would just plug these back into the second equation because it's easier. So I would do the 2 times the 4.65 minus 1. So you get about an 8.3. So this is the order pair 4.65 comma 8.3. And again, those are rounded off, but it's an x value and a y value because this is a system of equations. And then the 2 times the negative 0.65 minus the 1, which is going to give me a negative 2.3. So I get a negative negative 0.65 comma negative 2.3. And those are my two solutions. They should be expressed as ordered pairs because it's a system of equations. So I need an x and a y value for each. Okay? For this next one, if I look at this guy, we want to know when these are going to be the same. So again, this is a system of equations. I'm going to solve it by substitution because I already have y equals this, so I can plug that in for y. So I'll end up with a negative x squared plus 35x minus 8 equals a 3x plus 52. I'm going to subtract the 3x from each side. I got to get everything on the same side of the equation. That's a negative x squared plus 32x minus 8 equals 52. I'm going to subtract the 52 from each side. So I end up with a negative x squared plus 32x minus 60 equals 0. And then from here, if I want to check to see if this thing's going to factor first, I'm going to want to divide everything by a negative 1. I don't like to deal with negative a values. So that's going to give me an x squared minus 32x plus 60. Okay, and what I'll do is I'll take this off to the side and I will try to solve it. I'll try factoring. If factoring doesn't work, then I'll go to something like completing the square of the quadratic formula. I build a bridge. That's a positive 60. The two magic numbers are a 30 and a negative 2, so this one is going to factor. I can use my shortcut, so it's x minus 30. times an x minus 2. And now I set each factor equal to 0. And I'm going to solve each. So here I add the 30 to each side. So I find out that x equals 30. Here I add the 2 to each side. So that's x equals 2. And that answers my first question. The first question said, when will the attendance, on what days will the attendance be the same? And it's on day 30 and day 2. However, it also asks me what the attendance will be, so I have to plug these back in. Okay, remember this is a system of equations, and a system of equations needs an x and a y value. Okay, so I'm going to plug the 30 in. Again, I'm going to use this first equation because it's easier. So I'm going to plug the 30 in there. That gives me a 90 plus 52, which is 142. So that's the attendance on day 30, which can be expressed as the ordered pair 30, 142. And then I plug the 2 in. That gives me a 6 plus 52, which is 58. So that's the attendance on day 2, which is this ordered pair. Okay? So that sums up the number of days and the attendance on each day. Hope this was helpful, and good luck on your test.